All right, this is the lesson 5 practice, Algebra 1, SpringBoard, going over functions and functional notation. Lesson 1, use the beverage vending machine to answer number 1 through 6. All right, so everybody get a very good look at it. Hopefully I'm not going to have to go back and forth to it. List all the inputs are possible. I can push A, right? A1, B, B1, C2, C1, D1, then A2, B2, C2, and then D2. Those are all of my possible inputs, right? So A1, A2, B1, B2, C1, C2, D1, and D2. List all the possible outputs. Well, if I push those buttons, what happens? Right? If I push A1, I get coffee. If I push A2, I get chai tea. B1, I get juice, cocoa, iced tea, latte, water, mocha. What are the results if I push 2C? 2C, well, that's actually kind of backwards. But anyway, if I push 2C, I would get a latte. Right, 2C gives me a latte. Which number letter combination would input if you wanted to get juice? Juice, it says letter. Look at what it says. It says number letter combination. So that's what it's obviously wanting in order to get juice. Juice is here. So that's a 1B. That's where juice is. So 1B is juice. 5, in a mapping of the relation shown, what drink would 1D 1D would map to? 1D would map to water, right? Here is 1D, right? So that would map to water. And in a table of a relation shown by the vending machine, what number letter combination would correspond with cocoa? All right, cocoa is here at 2B, right? So cocoa would give you 2B. All right, which relation? Two relations are given. Explain. One relation is a function, one is not a function. All right, so again, how do we know if something is a function? The definition of a function is every input has exactly one output. All right, so if I'm taking a look, every input has one output, so it can't have the same input. So I got 5, -2, 2, and then -5. All right. This one would be a function, right? Because every input has one output, right? So I'm going to say this one is a function. Every input has exactly one output. Let's see, 5, -2, 5, -2. Okay, so the inputs 5 repeat, and they give me different outputs. So this one is not a function. That one's not a function because input 5 has 2 outputs. And the two outputs are -2 and 2. So taking a look at 8, seeing if it passes the vertical line test, right? You have the vertical line test to see if something is a function, meaning a vertical line will only touch once, right? It'll only touch it once from left to right. It'll only touch it once. So a vertical line, right? So if you have a vertical line, let's see if I can get a shape here. Use a shape as a vertical line. All right, so there is my vertical line, right? Make it longer. All right, vertical line, right? So this vertical line, right, as I move it from left to right, it should only touch the graph once. See here, that vertical line, see how it touches it twice? So that means that this is not a function because the input -2 has two outputs, 2 and -3, right? So this one is, all right, so this graph here is not a function. That graph there is not a function because -2 has two outputs of 2 and -3. All right, so taking my vertical line, and going from left to right down here. At no point does this vertical line touch the graph more than once. So this graph, this here, right? That one is a function. I don't know what I was trying to write there. It's a function. Right? Because every input has exactly one output. All right, let's go to number 9, looking at the mapping. All right, so the mapping, right? Remember, one input, one output, right? So for a mapping, all right, this is called a mapping, right? For a mapping, in order for something to be a function for a mapping, it can only have one arrow, right? One arrow per input. All right, see how this has two arrows? This has two arrows coming off of one input. So this one here is not a function. Input 5 has two outputs of 6 and 1, right? And so I'm going to use a different color. For this one, each one, even though it goes to the same output, each input still just has one arrow, okay? Each input still just has one arrow. So that means for this mapping, right, this would be a function because every input has exactly one output. Number 10, what values of x in the relation below would create a set of ordered pairs that is not a function? Okay, so what value of x, what is a value of x that I could, create? So if I say that if x will equal a number, right? If x will mean a number, is that it's not a function. Well, when is something not a function? When the input has more than one output, right? So if x would have to be an input value that we already have. Well, what are the input values that we already have? 0, 1, and 2. So if x equals 0, 1, or 2, the ordered pairs, because that's what it is, right? The ordered pairs would not be a function. Why? Why would it not be a function? Because an input would have more than one output, right? Because an input would have more than one output. Very good. It can't be 0, 2, 0, 1, or 2, because the x values already appear in the domain for the function, right? And none of them are matched with the range of 7. So it can't be 0, 1, or 2, because then if they were equal to one of those numbers, then the domain would have more than one range value. You would have more than one output. Is this graph, number 11, is it a function? Does it pass the vertical line test? If I drew a vertical line, right? I drew a vertical line and I moved it from left to right. Does it only touch the graph? Does it only touch the graph once? At no point does it touch the graph more than once, right? At no point does it touch the graph more than once. So is this a function? Yes. And if something is a function, we say it's a function by just stating the definition, right? What's the definition of a function? Every input has exactly one output. Every input has exactly one output. All right. Lesson 2. Lesson 2, it just wants us to use the graph, right? Use this graph, identify the domain, the range, and does the relation of the graph show a function, okay? Well, the domain is my inputs, right? And my inputs are my x values. All right, so my x values, right? My domain are my x values. So let's take a look. Let's just write the ordered pairs. This is -4, -5, right? So I have a -4, -5, -1, -5. This is 0, -5. And this would be 4, -5. All right, so there are my ordered pairs. All right, so my domain. Remember, domains have to be in a bracket, right? I got to put them in a bracket. I'm going to list all of my x values from least to greatest order, right? And no repeats. So I have a -4, -1, a 0, and a 4. All right, there's my domain. My range might be a little different. Listing them from least to greatest, nothing repeats. What is my range? Just -5. So all I'm going to write is just -5. Okay, that's all I'm going to write is just -5. Does this relation show a function? It's a graph. How do we test if a graph is a function? What do we use? The vertical line test. I'm going to draw a vertical line. Right? I'm going to draw a vertical line. And at any point in time, does this vertical line touch these dots more than once? Touch more than one dot at a time when I move it from left to right? No, it doesn't. So is it a function? Yeah, right? So we're going to say that, right, does the relation in the graph represent a function? The answer is yes. And if it's yes, then we state the definition of a function. Every input has exactly one output. Another reason why we know it's a function is because it did what? What did it do? It passed the vertical line test. Well, we can say that too. We can say, yes, it passed the vertical line test for a function. Okay. Lesson 5.3, use the function machine for items 15 through 17. How would you write the function shown in the function machine in function notation? Function notation is something that we just went over in 5.3. Function notation is that instead of saying y equals x squared minus 5x plus 8, we can call a function and identify it by naming it, right? We can call it the f of x. The f is the name, the x is the input, the f of x, right? And then whatever the function is. And that way we can identify what function that we're talking about. So writing this in functional notation, again, y equals and f of x equals. That's kind of the same thing. They're saying the same things. So this would be f of x equals x squared minus 5x plus 8. What is the value of f of 2? Well, what this is saying, right, is that if this is the f of x, then it's saying that the x is -2. So it just wants us to plug in wherever I have an x, I plug in a -2. So this is saying -2 squared minus 5 times -2 plus 8. -2 squared, that's a -2 times a -2. That's going to be a 4. -5 times -2 is going to be a 10. And then plus 8. And so that is going to be 22. So the f of -2 is 22, which means the output is 22. The y equals 22. What value or values of x result from when f of x equals 8? Well, if f of x equals 8, then we're going to substitute. That's not the input, right? An input would be in the parentheses, right? This is the x represents the input. Then that means that this 8 is going to represent an output. Okay? So what values would represent 8? So if 8 would equal to x squared minus 5x plus 8, I simplify that by subtracting an 8 by both sides, and I get x squared minus 5x equals 0. Okay? So what value of x will give me 0? Well, if x is 0, right? That's going to give me 0 squared, which is 0, minus 5 times 0, which is 0. So that'll give me 0. This is a callback to your problem number 8B, right? 8B. This is also a callback to number 12 on page 78. This is a callback to those numbers there. And then another value of x that would give me 0, right, is whatever number I'm multiplying this by, right? So if I were to say 5, right, if I would say x is 5, that would give me 25 minus another 5 times 5, which is another 25. 20 minus 25, 25 minus 25 is 0. So both of these work out. This is a callback to our 5.3 video for 8B and then also for 12 where I explain that a lot more in depth. All right. Last one would be number 18. Given the function f of x equals 2x, negative 2x minus 5, determine the value of f of negative 3. So f of negative 3, that's my input, equals negative 2 times negative 3 minus 5. That is negative 2 times negative 3 is 6 minus 5, which is 1. So the f of So the f of the f of negative 3 would be 1. All right. The first 7 numbers in the Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8. Use the items for number 19 and 20. So what this is asking here is what is f of 2? Okay. So this wants to know, well, hey, what is if that's my input, what is my second input? Okay, so if I look at my sequence, what's my second input? Well, there's 1, 2, 3, 4, 5, 6, 7. What's my second input? 1, right? So f of 2 equals 1. Well, what's my sixth? What's my sixth input? 5, right? So this would be f of 6 equals 5. All right. Dora said the mapping diagram below does not represent a function because each value of the domain is paired with the same value of range. Explain the error in Dora's reasoning. We talked about this, right? In mapping, when is it a function? What does it have to be in order to be a function in mapping, right? That was, what problem was that we talked about that? That was problem right up here, number 9, right? In mapping, you have to have one arrow per input to be a function. So we said that this one's not a function because 5 has 2 arrows coming off of it. But this one was a function, even though every input was going to the same output. Every input still had exactly one output. So we're going back down to 21. Why is Dora wrong when she says this is not a function? Yeah. Even though it's the same output, it's still every input has exactly one output, right? And so Dora is wrong with this because, and I'm gonna just type this up because it'll be a little easier, a little cleaner if I type it. That the mapping, right? The mapping represents a function because every input in the domain is paired with exactly one output in the range. Mapping represents a function because every input in the domain is paired with exactly one output. Sorry, that should be an output in the range. It doesn't matter if each domain value is paired with the same range, as long as each domain value is paired, right? As long as no one domain value, no input is paired with more than one, right? So if we had two arrows coming off of 6, we'd have an issue, right? If you had this, if you had 6, let's say there was a number 1, and 6 also equaled 1, that would not be a function, okay? But since we don't have that, everything is paired with exactly one input. One input is paired with exactly one output. We have a function. All right. And that is the lesson practice for lesson 5, activity 5, Springboard Algebra 1.